6. Oops. Oh, that's good. You never get used to that. Are you on? Do. Alive. Good boy. Hi, welcome back. Sorry, I was just keeping myself busy while I was setting up my phone to record. So today we're gonna commission this one. First, I need to reset its values to factory settings, if I know how to do that. Hope I do. I never do. Access code, save as factory setting. Oh, what's that? Where are you? With this setting, save the controller's actual settings as a new basic setting. Oh, no, I don't want that. If you need to return the factory set, it can be done this way. Cut out the supply voltage to the controller. Keep upper and lower button pressed at the same time as you reconnect the supply voltage. Keep upper and lower button. Okay, so the upper up one and the downy down one. We shall do. Oh, power off. Keep these two on. Give power. Factory. That's good. Even have an alarm. Oh, how lucky of me. E20. Do we know what E20 is? Of course we don't. The error of pressure transmitter. Oh, I need to configure this one. E45. Oh dear me, another alarm. Okay. So let's commission this one. We shall commission this to be a chiller or a fridge or a cold room working between 2 and 4 degrees. So set point it will be 2 degrees. So let's start with our first parameter. Wait, Adrian, today can you do this quite quickly? I commissioned this in half an hour. R01 is my differential. Let's change. What? Yes, it's 2 degrees. That's good. Moving on. R02 is maximum cutouts. So, oh yes, so that would be our high set point, how high we want the set point to alarm. Do recommend to put them quite close to their actual set point values, just prevents any unwanted visitors in messing about with the set point. So I shall put this at 5.5. 6 degrees. 6 degrees. 6 degrees. R03 is how low you can set the set point. I'll put that to -1. So -1 finally. R04 is our next one, which is correction of display temperature. No, I don't want to correct the display temperature. I want the real value. R04, 5 is display the temperature reading in Celsius. Can be Fahrenheit, but I'm gonna choose Celsius. We are in Europe after all. R09 is adjusted for correction of signal. So this would be our probe calibration. I don't want any probe calibration. Same as R10. R10 is our S3 probe calibration, which is none. R12 main switch. With this setting, manual control of outputs, main switch. Oh yes, so this one is set to 0. Yes, so we're gonna put this to 1. So R12, there are certain parameters in the controller which cannot be changed unless we stop the controller, which is done through this parameter. So we might need to go back to it in order to adjust certain parameters, but for now we're just gonna make this run for a bit. R13 is my night offset, night setback value. The thermostat reference will be the set point plus this value when the controller changes over to night operation. So I can set this to maybe 1.5 degrees. Okay, I'm gonna explain what it means a bit later, but just leave that to 1.5. So it will start at 3.5 degrees if the set point is 2 degrees. Next one, R14 is my thermostat function. So we've got a couple of options here: on, off thermostat or modulating. We can choose on, off thermostat. Modulating would, to my understanding anyway, would mean the controller. So if in on, off, you stop refrigeration at 2 degrees and then you bring back refrigeration at 4 degrees, in modulating, you never allow the controller or the temperature of the cabinet to reach 2 degrees or to reach 4 degrees. It will be somewhere in that region. So it will go maybe as low as 2.1 degree and as high as 3.5, 3 degrees, 3.6. So that's the way I understand this function. But we're gonna choose on, off thermostat. R15. Selection of thermostat sensor. Yes, thermostat sensor. I'm gonna put 50% because I want the thermostat to be the average between the air on and the air off. Sometimes you see them at 0, sometimes you see them at 100%. They can be 40%, 60%, or 50%. So I chose 50%. So if my air on temperature is 4 degrees and my air off temperature is -1, the sum of these two temperatures would be 6 degrees. So my thermostat value and the display value will be 3 degrees because it takes half of that 6 degrees. So that's what it means. R16. Moving on is melt interval, only for control of refrigeration. The function ensures that it evaporates. We're going to choose this to be 1. Where is 1? 0. Just because we're going to have our defrost schedule. So I'm going to choose R16 to be 0. R17. What is my R17? Melt period. Here you set how long ongoing melt function is to last. Leave that 5. I don't need to worry about that. R21 is set point number 2. The thermostat cutoff value when the thermostat band 2 is activated via digital input, similar to what we did on this one, sorry. So I want to use my second thermostat band because I'll be wiring this switch into this one as well. So the advantage of this controller is that it's got 3 digital inputs. So this one is quite versatile. Be more trickier to commission, but I'm sure we shall succeed. So my second thermostat set point, I want that to be, let's just say it's at nighttime. To make it more energy efficient, I shall put that to 3.5. Oh, let's make it 3 degrees, 3.5 degrees, just an example. So yeah, that's my second set point, 3.5 degrees. R59 is adjusted correction of signal from S6. That would be our product probe, not the one in here. So we have, I hope I'm not wrong, air on, air off, evaporator in, evaporator out, defrost probe, product probe.